of the project is going to be that we are going to add a surcharge onto our soils before we build the structure. So same structures, in other words, no change in the soil profile, same thing. In fact, yeah, same soil properties. Now, notice we have an OCR here, and what we're going to be doing is we're going to change the sigma prime P, the pre-consolidation pressure, by adding the surcharge. We're going to have the same cases, but we're going to add the surcharge. So all the same cases. And so we are going to do this, okay? So we're going to assume that you put 40 feet of surcharge fill at the site for 25 years. So a long time, basically. We're then going to remove the material, and the unit weight of the material is 100 pounds per cubic foot, which means that we are going to put on 40 times 100, which is 4,000 PSF. And what we're going to do is you're going to get the new pre-consolidation pressure, which is pretty straightforward in a sense. We're going to add this 4,000 to our sigma prime I, and that's going to give us a new sigma prime P. Now, what we're going to have to do then is we're going to compare the sigma prime I plus 4,000 to our previous sigma prime P. Okay, so that if sigma prime I plus 4,000 is greater than the sigma prime P previous, then what have we done? We've increased our sigma prime P, so that sigma prime I plus 4,000 is going to be the sigma prime P that we put in this table here, which is our with surcharge settlement calculation. And on the other hand, if sigma prime I plus 4,000 is less than the previous sigma prime P, then the sigma prime P in this table is going to be exactly the same as the sigma prime P previous. And what does that mean? That means that there's no change in our settlement calculation. It's exactly as it was before. All right, so I'm going to do the cases that we did previously, which is case 1.6 and case 2.2. So to give you an example. All right, so if you remember, for case 1.6, we had layer 6 and layer 8 were the compressed layers. And if we look at our data from the previous one, we had sigma prime I for layer 6 was 4790. For layer 8, it was 9226. So I'll just show you that. So for layer 6, the sigma prime I was 4790. The sigma prime P was 5317. So let's check that out. Then that means that we had the sigma prime I of 4790. If I add 4,000 to that, I get 8790. That 8790 is greater than the previous sigma prime P of 5317. So that means that my sigma prime P for this new calculation is going to be 8790. On the other hand, if I look at layer 8, so layer 8 is still case 1.6, I have my sigma prime I of 9226. If I add 4,000 to that, that means that my number is 4,000 plus 9226 is 13,226. Well, 13,226 is less than 16,700, so I haven't made a change. I have not improved my sigma prime p for layer 8. So that means that when I do layer 8, my sigma prime I plus 4,000 of 1326 is less than 16,700, so there's no change in the settlement, and I simply put the numbers that I previously calculated for the center, edge, and corner. They go right there. So that's an easy one to take care of. On the other hand, for layer 6, I have those new numbers there. My sigma prime f has not changed. In other words, we take the sigma prime f straight from these numbers here, 6623, 5671, 5214. So I use those same numbers right there for my sigma prime f, and I calculate a new epsilon v. Well, how do I do that? Well, notice that my 8790 is bigger than all of my sigma prime f, so I never hit the sigma prime p, and that means that all of the settlement is in the range with the C epsilon r, of 0.083 for this layer. So I simply take, so I don't use that, I don't need to use it. I just take this over that, this over that, this over that, and do the logs, of course, and I get my new epsilon v's. My h for this layer is 56 feet, and I get my delta h here. So in other words, epsilon v times my h gives me my delta h. So I get the two layers, I get the two compression of each layer, so I add that, the 654 and the 0274, I get that. I add those two numbers together to get the edge, and then I add those two numbers together to get the corner, and that gives me my settlement for case 1.6. Now for case 2.2, all I had was layer 4 that was compressed, and that has an h of 7 feet. I'm not going to go back and forth, but you can do it yourself. That's my sigma prime I. I add 4,000 to it. That 4,000 is greater than the sigma prime p previous of 2,400. And so I've done improvement, so I'm going to use that number for my sigma prime p. And what do I find? There's my sigma prime p. These are my sigma prime f's. And my sigma prime p is greater than my sigma prime f in all cases. So again, that means that I never hit the pre-consolidation pressure, and I simply do these ratios, that over that, that over that, that over that, with my C epsilon r of 0.106, and using log, of course, and I get these values for my epsilon v. There's my h. Those two together, multiplied together, gives me these, and I now have my settlement for case 2.2, center edge center, edge, and corner. So I now take those values and I plug them in to my table. And so if I take my center to edge differential settlement, I get that. My center to corner differential settlement, I get that. And edge to corner differential settlement, I get that. This is for case 1-6. The L's we've previously computed. 40, 56.6, 40. And what do I find? That's 1 over 128, 1 over 114, 1 over 216. It still fails. Fail. So I tried by adding a surcharge, didn't help me any on that. But let's look at case 2-2. What do we find? Well, now my center to edge differential settlement is 0.11, center to corner is 0.184, edge to corner is 0.0738, and then I have my L's 40, 56.5, 40, and now I have 1 over 363, that passes. 1 over 307, that's passes. It was 1 over 300, which was our criterion. This is 1 over 542, that passes. So this is a case that we've improved. So now we have a new case that works with the surcharge. So we have another option for our client to create a foundation. Okay, so we can show all of those. So what you need to do is fill out the tables for each one of these. So fill out all these tables. Fill out this table, obviously. So for this part of the project, you fill out this page, this page, this page, this page, this page, this page, and this page. And we will learn what other cases work.